What a nice location. I really have to say that. I mean, I've been to every NGDE, actually my second time just as a speaker, but this is an amazing location. I really love it, and I'm even more happy that we are back in Berlin again. It was last year in Bonn. Who was there last year in Bonn? Yes, I'm British. Berlin is it's just Berlin. I love it. I love the location. I love the people. The beer might need still some work over here, but it's fine, it's fine. So yes, as said, it's the last talk of today. And also as mentioned, I need to catch a flight because I'm traveling immediately to Athens. Unfortunately, I love running so much that I want to run the original Athens Marathon, where basically, maybe you don't know, but the person who ran it first died after the finish line. So let's see what's happening on this Sunday. But yeah, as said, just reach out and ping me on LinkedIn or email. I'm really happy to answer any kind of question. Coming back to my topic. So when you think about securing an Angular app, what might be the first attack that comes into your mind? It might be cross-site scripting, because we ship a ton load of JavaScript to the client. So actually, the second question we ask ourselves, but is cross-site scripting actually still a thing in Angular? We have the Angular sanitizer, right? It does so many great things for us. Like whenever I try to bind something malicious to the Angular template, the Angular sanitizer will say, no, 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 I sanitize this for you, and remove everything that might appear malicious. So let's look at this kind of snippet. It's an all-time classicer. It's like an image tag, and we have a source attribute. And what does the browser do if the image will not be found? It will immediately call the on-error callback, and then JavaScript is executed. That makes us sad. But luckily, Angular Sanitizer to the rescue. The Angular Sanitizer recognized that and says, nope, not with me. I will remove it. So far, so good. But I don't know about you, but when we take a look at this graph and we see like 3 attacks in comparison, like SQL injection, the purple one, cross-site scripting, the red one, and the blue one, Cross-Site Request Forgery, somehow cross-site scripting is still increasing. We have here the years basically, and from year to year, it's still increasing. And even like the last years, where single-page application got more and more cross-site scripting prevention strategies built in, it's still increasing. And right now, I mean, we have the beginning of November, and we have still the same amount of vulnerabilities based on cross-site scripting like the last year, but there's still 2 months to go. So, and as I always say, in winter, people tend to stay home a little bit more, so the hackers might also be a little bit more have fun to stay at home and do some attacks and playing around on your websites. If you're still not convinced, take a look at some bug bounty and pen testing reports. They introduced, or like what they discovered is that XSS is still the most discovered vulnerability in our web application. As well, for pen testing, there are still so many cross-site scripting vulnerabilities who they found when they did some pen testing reports. Of course, you might say, what the heck? Can't we? This cross-site scripting is so old, like my grandmother. Like, why is it still happening, actually? And I'm here to answer the question, and I'm also here to answer the question, can we not finally do something about it? Like something that really works well and eliminate completely cross-site scripting. So can we at least make it a lesser thing? Because one thing I want to foreshadow, we never will get rid from cross-site scripting if we keep the browsers in that state of backwards compatibility like they are. Like they still need to support HTML4 and whatnot. So, okay, let's take a step back and take a look how we at least can make it less a thing and maybe have some decreasing vulnerabilities on cross-site scripting. First, a few words about myself. Yes, hello, I'm Martina. I'm working mainly as an app security engineer, but I'm coming from Angular. I worked with Angular.js and then Angular. For that, I'm also a GDE in Angular. I like to state my opinion onto a lot of groups, so I'm involved in some security groups. I'm also OWASP member. And lately, luckily, I also am allowed to call myself a GDE for identity, since I'm also writing a book about the whole topic of identity management, authentication, authorization in web application, or all things OAuth and OIDC. But the most important thing is that I have 2 beautiful cats. Aww. It's called Lenny and Raupi. Aww. I'm already 1 week completely away from them, and I never thought I will miss my cats so much. But I do, because look at them. Aww. Okay, enough. So if you also want to ask something about my cats, I'm more than happy to answer this as well. Okay. Cross-site scripting, what is the issue? The issue is that whenever a user types something into an input field or maybe a query parameter, and we immediately assign it to something like a dangerous API, like inner HTML, without actually validating it. Luckily, as said, we have the sanitizer over here. But I will show you shortly that you can do it still in an Angular app to actually do a cross-site scripting attack. For that, I have an application. It's called Kittygram. It's like Instagram, but you're only allowed to upload kittens because for obvious reasons. So what I have here, you can basically search. Yes, it's really exciting. You can actually search for a cat, and then what you see is basically the term over here, what you have searched for, and you also have this query parameter in your URL, because obviously you want to copy that and send it to your colleague, which hopefully also, did I kill it? Oh, did I kill my little cat? Seems like I killed the application. But all good, we were getting there. So my kittens will be shown again. There are my kittens, so I copy-pasted just the URL. Sorry, I just missed NPM start before the talk. So everything is like it's supposed to be. The crucial part is now, what happens if we put some cross-site scripting malicious JavaScript code in this global search field? And global search fields are really often misused of actually injecting malicious code. So I brought here some 3 great examples, which are like a typical malicious JavaScript code, which are other forms of executing JavaScript other than using the script tag. Iframes, and we love iframes as hackers. Iframes are doing so much good stuff for a hacker because we can do so many things in your browser with an iframe. Image tag, we already saw, image tag example, we already saw it. But of course, SVGs are also doing a great job. As soon as they get loaded, the callback gets loaded, and we will also have a JavaScript execution in your browser. So let's copy that, and let's insert it here in the search field. And yes, of course, it will be a cross-site scripting attack, otherwise the demo would have now really boring. The issue about this is that it didn't get sent to the server because it's completely client-based. The search, it's not a server-side search, basically it's a client-side search. So the server doesn't get anything to know about, a user really tried something. It just happens inside a web browser. And for more, now I will send you the link, and maybe I will completely steal all your access tokens you have in your local storage because you put your access token in the local storage, which is also something we might need to talk about. But you click on this link, and then the JavaScript execution happens in your browser. You might now tell me, but Martina, I never, ever would click on a URL which has something like iframe and JavaScript inside it. Yes, but you just scan QR codes. Freely around. A lot of persons have QR codes on their slide, and you just scan it without maybe really taking a look what it leads to. We have a lot of URL shortener. LinkedIn, for instance, when I copy-paste the URL into LinkedIn, LinkedIn shortens that for me. And I don't know what lies behind, right? I just click on it because the post says, yeah, you can get some free kittens over there or whatnot. So it's a real issue. We don't know what lies behind the URL, actually. So yes, we might need to really think about finally getting rid of XSS. But first, coming to the point, why was this possible in my Angular app? Yes, because I did something really great. I injected that sanitizer and called a function that's naming bypass security trust HTML. Just as a short side note, whenever there's a function with a prefix bypass security, not good, just in case you're wondering. But still, people are doing that. I mean, sometimes we have what you see is what you get editor. We want a text area, for instance, and we want to insert some HTML. And we want to bind it to the inHTML property because it should be rendered. There should be rendered HTML for that. So we need to tell Angular, you don't have to sanitize it. I trust me, I know what I'm doing. But furthermore, nothing and no one really keeps us apart from doing something like, yes, document, get element by ID, and put something directly into this div, for example, and then calling inner HTML and assigning something directly to inner HTML. Everything is JavaScript. The DOM API is accessible from our Angular app, of course. And unfortunately, like a couple of years ago, there were still persons telling you this is fine to do because we had this change detection cycle thing, which slowed down a lot in Angular from time to time, depending how we used it. So people got consulted. Yeah, sometimes it's fine to just call the DOM API directly. Just as a short note on this, it was not fine at all. It was less secure, and it didn't improve your performance at all, to be really honest. But yes, some people run around and say this could fix all your performance issues. So to state it out, you can't control the whole code. I mean, we saw two examples, and every one of us is sure we never would use something like that. We never would call the bypass security function, and we never would directly call the DOM API. But it's hard to control the whole code. I mean, we have micro frontends, we have enterprise applications, we have PRs to maybe take a look into it, and it's not really, really easy to always follow all the cross-site scripting rules, basically, and always make sure that you use the sanitization mechanism built in from Angular correctly. Luckily, in security, we have something that is called defense in depth. Means when the first line of defense breaks, there's a second line and a third line. And the second line got introduced a couple of years ago. It's called content security policy. Who of you ever heard already of this HTTP header? Yes, I like it. I really like it. Unfortunately, when you see some stats, just 20% of the websites are using content security policy, which makes me really sad. And if I'm sad, my cats are sad, and then I'm angry. So please try to really implement the CSP into your project. What is it basically? It's an HTTP security header. It comes with two modes. And it basically, you set up a policy like JavaScript is only allowed to run on my website if it's coming from my own origin. Or you do something like, yes, okay, I have an inline JavaScript on my website, on my index HTML, and only this inline JavaScript is, for instance, allowed to be executed. I can mark this as valid for the web browser, and anything that violates this, like a JavaScript injection attack, violates this CSP, the browser will block. This is really cool. This is really, really good. It comes in two modes. It's enforcement mode and report-only mode. When you start a greenfield Angular application, I always would recommend to completely apply immediately a default CSP and use the enforcement mode, but you can't do this always. When you have a huge microservice and you just use, okay, CSP enforcement, let's go for it, then your whole application is, of course, broken because the CSP might block too much. So one solution could be then to enable it as a report-only mode, which basically means the browser is not blocking it. Yes, it's then not really secure in that sense because nothing is blocked, but you will get basically a report JSON. And so the browser creates a report JSON, what policy was violated, with what kind of call and what not. And then you also provide a so-called report URL inside the CSP, and the browser sends you this report JSON. And this is amazing because out of the sudden we do get a report whenever some XSS attack might occur inside the browser, even if a server isn't involved. This makes CSP for sure already really, really great. And it's even more greater that Angular got you covered on that as well. Since V19, Angular has the possibility inside the Angular JSON to set auto CSP to true. What it means, whenever you run a build production, you get already inside the meta tag and content security policy and default content security policy. With that, you can basically start. What I haven't tell you, I said this isn't response header, but usually from time to time, some response headers you can actually also set as a meta tag with this HTTP equiv attribute you can use, and then it's kind of an equivalent like you would have set the response header. Yes, you might need to be careful. There are some CSP policies which you can't set on the meta tag, but you can set it on the response header. But most of the things for JavaScript injection, you definitely can also set in the meta tag. Okay, we are good. That's perfectly fine. That's fixing all our issues. But wait, we have NPM packages, right? So let us think about these NPM packages. When we are downloading them inside a web browser, they're coming from our own origin. Oh no, they're coming from our own origins. Seems like CSP marking everything that's coming maybe from our own origin as valid, and the browser executes it. Okay, that makes us sad again. And even more, what should us make really sad is what happened this September. A lot of NPM packages got compromised. A lot of NPM packages, because many developers just don't care about supply chain attacks on NPM, like maybe checking the integrity or doing some integrity checks before letting NPM just install everything freely. And another fun fact, you don't even need to have this kind of supply chain attack. The fun part is you don't know how many packages are out there that have something like anukla/something. It's called typo squatting. We installed Angular Material, Angular CDK, Angular CLI. We installed it already so many times that we sometimes don't even look what we are typing. And if we make a typo, and there might be a package out there like Anukla CDK, it will be installed. And you won't recognize it, because you might also don't look immediately after you install the package inside your package JSON. You just install it, and that's fine. And there are a lot of packages out there in NPM which make use of this kind of typo squatting. This makes us even more sad. So you don't even need to have a let's say, supply chain attack, which is really bad. You can also make use of this typo squatting. And according to NPM, the stats are already like 1 year old, but I think it's definitely still valid. 97, I mean, think about it, 97% of our web applications code is coming from NPM. Why are we trusting them so much? Maybe sometimes, a little bit, sometimes we should go to the direction again that we can do it better than an NPM author. Just sometimes. I see, for example, a lot of projects, they're installing an NPM packages just to have an enum of the HTTP status codes. So the NPM package doesn't do anything more than giving us an enum of HTTP status codes. And it's like, what? Can't you just create this enum, please, on your own? And there are a lot of more examples. So maybe we can think about developing more on our own again. Not maybe always with the AI, because in AI and security, I have a lot to say about this as well. Nevertheless, staying with cross-site scripting. And when we're taking maybe even 11 steps back, what is the real issue about cross-site scripting? The real issue is that we have some APIs inside the web browser which allowing us to assign strings directly to this API, and then the API is basically concatenating it and bringing it to the DOM, rendering inside the DOM. This is the real issue. If let's say we would remove all these APIs, actually cross-site scripting could be solved. We can't do that because half of the internet, I'm pretty sure, will break down then, but we can do something else. We can create something that's called trusted types. It's a new kind of new browser API. Actually, it is already in the browsers for more than 3 years, but it's barely known, unfortunately, still. So what is trusted types? Trusted types basically means, okay, we see this inner HTML, this is a dangerous thing. So really, really, we should actually not use it. But yes, we tend to use it, but then at least have it as a trusted type. So if we enforce trusted types, we tell the browser every assignment to this kind of dangerous API needs to be the specific kind of type, a so-called trusted type. And when there is this kind of dangerous assignment to inner HTML or document write or whatnot, then, and trusted types is enforced, then we get an error message. And so to sum it up, so when trusted types enforced, the browser rejects just any kind of normal strings that are passed into these APIs. And we need to create explicitly these kind of trusted types whenever we want to have an assignment to this kind of dangerous APIs. How to enable them? We put inside our content security policy a flag called required trusted types for script. So let's see how this works with our issue, with our XSS issue over here. As see, right now we still have it basically, so it's still like this cross-site scripting attack. And it's really easy. We just have it here in our index HTML. And I uncomment this. So what I do is like enforcing trusted types for my browser. And then, of course, the XSS attack can't happen no more because it says this document requires trusted type assignment. Okay, ta-da, everything is fine. Yeah, but how do I do this trusted type? How do I create a trusted type now on my own? Because maybe I do want to assign something to this dangerous thing, and I need a trusted. Okay, I need to create this trusted type. How do I do that? But there's also an answer to that. It's a so-called trusted type policy. It's a browser API, and you define a policy. And only this policy is now allowed to create trusted types. It's part of the official trusted type API. It's a browser security feature. It's already implemented in almost all browsers. I will come to that later. And we define our policy. And whenever the browser sees this, executes this kind of assignment to an inner HTML or any other dangerous API, the browser calls the policy, and the policy creates the trusted type. So how does it look like? Yeah, it looks like this. It's a trusted types object, create policy function. I give a name to my policy, and then I have some callback methods. Maybe if you know, Angular defines this kind of security contexts. We have an HTML, we have a script URL, or we have style. Depending on the context, I might need to implement another callback, like create HTML, create script URL. But we keep it simple. We just have this create HTML function, which will implicitly be called whenever now I have an inner HTML assignment. And then I just use the policy to create this trusted type before I actually assign it to maybe some dangerous API. Okay, but the hacker can also create a policy, can't they? I mean, they can't just like, again, create this policy and put it also into my inline JavaScript, and then the other policy might also be used, right? No, there's one missing single link. Inside the CSP, we're restricting which policy is allowed to be used. So let's say a hacker even tries to define their own policy. In either way, it's not policy anymore, yes. It's not possible anymore, since the inline JavaScript wouldn't be able to be executed in the first place because it's not a trusted type, and it can't be a trusted type because the hacker can't create a trusted type because the hacker can't use my policy for that. That sounds pretty good. But it gets even better. Yes, we saw a lot of code like this trusted type dot create policy. But you know what? We don't create our own policies. Angular got you covered. Angular has a built-in trusted type policy. And you basically just apply it to your content security policy. And the best part about it is, whenever now you're using the Angular API, for instance, and the sanitizer of Angular kicks in, it returns your whatever you wanted to bind as a trusted type. So when we're using the Angular API, we are safe. Everything is fine. You can surely and really easily just enable them in your web browser. Okay, we have this thing like bypass security trust HTML. Yes, there's also another policy you can just enable. It's called Angular #unsafe bypass. And even if you call this bypass security trust HTML function, Angular still returns it for you as a trusted type. So we also have that part really secure. But if you call this bypass trust security HTML, you are responsible for that. It's really trusted. Like, you have to sanitize it on your own, of course. Angular marks it just as a trusted type, but if you don't take care about that it's properly sanitized, then we are still screwed. I mean, then for the browser, it's a trusted type, but it's still dangerous. So you're responsible then, of course. You still, of course, need to take care of this part. So why can't you just easily bypass trusted types in this XSS attack? Let me sum that up. You can't create a trusted type on your own because only the applications policy is allowed to do that. And the moment where we register the policy, at that moment, no JavaScript is somehow interfering. It's an HTML parser, and when the HTML parser runs, there is no JavaScript involved. So you can't, another inline JavaScript attack can't just add another policy somewhat in this meta tag. That's not possible. And in this meta tag, as we saw in the content security policy, you just register this kind of policies, and basically you're not registering it, you're restricting them, like which policies are allowed to actually create this kind of trusted type. Yes, the browser support. Chromium-based web browsers are good. And yes, trusted types got really pushed by by Google, of course. And unfortunately, the starting of trusted types was actually from Mozilla. And then I guess they had some more important things to do, and they still have it. But now, Safari joined the board. Safari is supporting trusted types, and maybe what's happening right now, Frederick, like the security person from Mozilla, they had like one of the security engineers on Firefox said, I mean, he didn't tell that. It was just like my assumption that he thought maybe something like, if even Safari does it, damn it. Okay, let's start it. So if you want to follow along about the progress of Firefox, here's a Bugzilla track link even. But even if you want to enable trusted types in your web browser, you can do that today already. There's an official polyfill you can just use. And for Firefox, but all the web browsers, Chrome is supporting trusted types already for such a long time. I'm really glad I could give so many information about trusted types. I'm even more grateful that you stayed till the end of the day. I'm pretty sure you're more excited about the Q&A panel right now. But thank you so much for bearing with me, and have a great time at this great conference. Thank you.